Vision is the most used human sense, but it's gaining ground in the machine community too. Hi, I'm Jim Montague, and welcome to Part 2 of Control Design's 2010 Market Intelligence Report on Sensors and Vision. Part 1 focused on basic trends in sensors, while this portion will explore how machine vision is being used for sensing and what technological shifts might be happening. To gain these insights, we once again surveyed Control Design's readers to get a snapshot of the types of sensing components they employ on their machines and production lines, including those that use machine vision. We asked how they're connecting to I/O and what they're using machine vision for. We've also asked Ned Lecky, founder of Lecky Integration in Little Falls, New York, to come back and provide some fresh context and analysis of our survey results for 2010. Lecky is a mechanical engineer and electrical engineer with 25 years of experience in control systems and machine vision. As owner of Lecky Integration, he consults for OEMs, system integrators, and machine vision providers. We'll ask him for a system integrator's interpretation of our findings right after this message from our sponsor.
Fast, flexible, reliable. Matrox Iris GT Smart Camera with Design Assistant software. The Matrox Iris GT Smart Camera is IP67 rated for demanding environments and is powered by an efficient Intel Atom embedded processor. With Matrox Design Assistant software, applications are created by constructing a flowchart instead of writing traditional program code. Visit our website today to download a free trial of Matrox Design Assistant software.
Okay, welcome back again. Surprisingly, just 36% of 2010's respondents report using machine vision-based sensing. This was a sharp decline from 2008 when half used it. Of those that do use vision-based sensing in 2010, 57% reported using vision for online inspection, 30% used it as feedback for real-time machine control, 7% used it for online inspection, and 2% each used it for worker inspection, measurement, spectroscopy, and other tasks. Almost exactly the same percentage used vision for inspection in 2008, but only 23% were using it for feedback for control. Well, Ned, I'm wondering if this result has more to do with industries these respondents work in rather than an actual reversal in implementation. One encouraging result from these users looks to be the increase in using vision as a real-time control element. This is your field of expertise, so in your view, is it a growing sensing technology in some industry segments more than others, even if it would be useful in those others?
Yeah, well, it's an interesting question, Jim. The thing about vision that is frustrating, even after all of these years, the computers that we have for doing image processing, machine vision processing, are very, very simple compared to the visual processing system of a human being. And so what we can do without even thinking about it as an image processing task becomes a pretty complicated job for a machine vision system. And there are a lot of aspects that we've learned over the years that are very, very important to deploying vision and having it be successful in a real-world application. You've got to get the lighting right. You've got to get the optics right. Things have to be presented properly. Part presentation is always a big aspect. And there's also a lot of learning curve that goes on. We deploy vision in an application, find out that things aren't exactly the same as what you thought. Maybe there's some more variation that you're supposed to be able to tolerate than you really knew about. And so there's quite a bit of investment that has to go into making a machine vision application work. Many times that investment is not made and the machine vision application fails. And most people in machine vision have had experience with many applications that just didn't work out because of that lack of the ability to invest. So what that means in 2010 is we're smart enough now to only try to deploy machine vision in a place where we're really going to get a big bang for our buck. If someone is manufacturing 3 relatively simple assemblies a day and they need to be inspected to make sure that all 38 bolts are in the holes, quite frankly, it's just going to be a lot easier to have Sally or Jeff take a look at those things and make sure they're okay before they go out the door. And honestly, Sally and Jeff are going to notice other things than just the bolts that we didn't even think about. They're going to notice that there's a chip in something. They're going to notice there was a scratch on something. They're going to notice that this one was dropped and has a big ding in the corner. They're going to notice things that your machine vision system won't notice. So for most manufacturers, I think, if they can afford a simpler kind of inspection methodology, it makes sense. Now, if you're manufacturing very, very high volumes of parts that need 100% inspection, it may get to the point where there just aren't enough Sally and Jeffs in the world to look at all of those components, and now you're forced into a machine vision kind of high-speed inspection solution. I think that in 2009, 2010, I think there have not been as many deployments of those high-volume manufacturing applications in North America as there were in the past. I think we could talk about that statement for a very, very long time about why and what we hope we might be able to do about it. But that certainly is a major factor. You know, you're going to find the machine vision applications where you have high volume manufacturing, and furthermore, the machine vision applications are going to make sense where you have high volume manufacturing coupled with high cost labor. And in the global economy right now, we've moved away from that combination very strongly. Now, real-time control, I'm not at all surprised to see that that's a growth area for machine vision, because this is one where machine vision does a very, very good job. If you need a real-time control, for example, robot guidance to pick up a part off of a conveyor line, for example, or if you have some sort of a motion control system, that needs feedback based on the location of a part on the platter, not just the platter position itself. Certainly tons of applications like this in semiconductor. I mean, that's what really created machine vision in many ways. Then machine vision is going to make a lot of sense. So I think coupled with what's going on with high volume manufacturing and high cost labor, I think your numbers make sense.
Now, smaller percentages of this group are using all-in-one integrated cameras compared to last year. This year, 37% used all-in-one integrated smart cameras. Last year, 60% said they did. Meanwhile, 31% are using vendor-built systems with camera, frame grabber, and processor, and that's similar to prior studies as well. Also, 14% are using integrator-built systems with camera, frame grabber, and processor, and 15% used integrator-built systems. Ned, here again, this might be more to do with specific industry segment differences compared with prior years. Can you outline the reasons why particular applications are better served with one of these choices more so than the others?
Yeah, it's been really interesting to watch kind of the rise and plateauing, I guess, of the smart camera-based kind of solution. Where we are right now, if we just kind of jump to the current situation, we've got very high performance, low cost cameras. I mean, we're talking about, multiple hundreds of frame per second gigabit Ethernet cameras that are selling for a few $100s now from multiple vendors. This is a very high video performance, and that camera can be plugged into my laptop, and I can acquire video at 100 or 150 frames per second. I can even display a lot of it. And with the kind of processor technology that we have now, the multi-core processors running both Windows and Linux, another very attractive option for multi-core programming. It's possible for what I'll call non-rocket scientists to build up their own machine vision systems, using these key components. So it's not at all surprising to me, even though I think this 14% using integrator-built systems with frame grabbers. I mean, this sounds an awful lot like 1985 or something. There's a big. There have been some major phases that we've skipped through where it started that you had to build your own vision system, and then it went to the point where there were a number of companies, Intellidex, Automatics, Cognex, building fully integrated machine vision computers, and you would just buy one of those and plug a camera into it and not have to think about hardware. Then we went to the smart camera, which is a wonderful concept of taking the camera and a single board computer, kind of marrying them together in an individual box. For many applications, that is the best possible solution that you can come up with. But it's very easy to get into an application that requires more processing power than you're going to get out of that single board computer. And in many situations, the cost of a camera plus a small computer will be less than the cost of that lower performing smart camera system. And I think that's what has contributed to the decline in the popularity of the smart camera system. So it's very high powered computers, and very low cost camera components with high resolution. The proliferation of really easy to use software packages and libraries to help people to get started. I think that has opened up the door for a lot of different ways to create machine vision systems and to not be afraid to do it yourself, which I think is a really positive development in the industry.
To set up their vision-based sensing systems, users have to employ configuration software, some that are easy to use and others less so. Almost half of 2010's respondents report their vision configuration software has good functionality and is easy to use, while 26% say they have good functionality but their software is hard to use, and 17% say their software's functions are marginal but it's still easy to use. These results are comparable to 2008. Ned, the results over time look pretty consistent here. Haven't there been many recent advances in configuration software for machine vision? So shouldn't vision technology for sensing have a better report card for good functionality and ease of use?
Boy, I sure wish that we could come up with a way to get a better report card for ease of use. I mean, in some sense, this ties back to something that I alluded to earlier. The computer that we use for image analysis and image processing is just a radically different machine than the computer that is on the desktop that we plug cameras into and try to use for the same operation. No matter what piece of software you use, and at this point, most of the software packages have more or less feature parity. It's the differences are we really get into the short hairs and the minutia, at this point. The problem is that computers just don't work the way the human brain does. You can show a person what an assembly looks like and say, this is the top, this is the bottom, this is the faceplate. The faceplate can't be scratched or cracked. The top needs to have all 6 bolts. All of the bolts are supposed to have this particular hex head shape on them. There's a label on the bottom. The label is always supposed to have today's date. The label's supposed to be straight. The label corners are not supposed to be peeling up. And I can go through that with a person, even a not highly skilled person. And with a couple of repeats, we can have a very, very highly functioning inspection system. Whereas you might spend a year trying to set up a computer-based machine vision inspection work cell that did nothing more than the tasks that I just listed. And of course it's frustrating, but it's not really a problem with the machine vision industry. If that were the case, it would have already been solved by any one of the smart companies that are involved in our industry. The problem is computers don't work the way we really want them to in order to do image processing, and that's what forces us into recasting the problem as something much, much simpler in order to be able to write a computer program that implements that. Right? So unfortunately, I'm afraid that the next time we ask these questions, we're going to get about the same numbers. I don't see any reason for the software to get worse, but unfortunately I don't see a lot of reasons for it to get better, as hard as we're all trying out here to come up with great ways to do that.
Finally, the 2010 survey asked what kinds of communications links users deploy for their vision systems, and 34% report using Ethernet, 16% use hardwiring, 12% use fiber optics, 8% use universal serial bus, 7% use serial networking, and 5% each use camera link, FireWire, and Gig-E Ethernet. These These results represented an increase in users over the 27% that reported using Ethernet in 2008 and a decrease from the 26% that used hardwiring 2 years ago. Well, Ned, this looks like more evidence that Ethernet is taking over. Have FireWire and CameraLink run out of support in newer systems?
Well, one of the things that was explained to me, I graduated from college, my undergraduate years in 1984, and I went to work for a company that was manufacturing systems for printed circuit board inspection, a company called Control Automation. And we had analog cameras from Polniks that we used in our systems, and the cameras didn't really have the specifications that we wanted. And what was explained to me by the CEO of the company, which made perfect sense, was that the issue is that the machine vision industry is not large enough to warrant the design of a special camera. I mean, we don't really drive the industry. There are much bigger things going on that are driving what happens in camera technology. Now, these days, there are a number of vendors that make a great many machine vision specific cameras that are very high quality and very specific and have the kind of features that a machine vision person would want. External triggering, the ability to handle strobes, very high speed shutters, very high frame rates. We get all that stuff. But the reason we get that, quite frankly, is not because the machine vision industry has enabled the development of all of this technology. The bits and pieces that are in those cameras are things that were developed for some other much higher volume application. The sensors, are coming from Kodak, Sony, other companies, DALSA. These sensors have been designed for very high volume applications. The electronics inside are based on FPGAs or DSPs that were designed for very high speed control applications or data analysis, signal processing kind of applications. And then comes the communications. The communications is designed for general purpose data communication. And one of the things that has happened with FireWire and to a certain extent CameraLink and also to a certain extent USB, I think, these interfaces were designed for to facilitate high-speed communications between different types of devices. Now, in the case of CameraLink, it was designed specifically for interfacing to high-speed cameras. Right? In the case of USB and FireWire, kind of had a more general-purpose design intent. What's happened with Gigabit Ethernet is it has sort of trumped these other interfaces. It operates over a much longer distance, 100 meters for Gig-E. Nothing else goes that far, and that distance is very, very important. The interface hardware is very inexpensive because you'll find it in effectively every computer device that's sold in the world. That's a bit of an overstatement, but not a tremendously huge overstatement. And because it is such a popular interface, behind Gig-E is 10 Gig-E, which already exists, and you can start to buy products running at 10 gigabits per second, and then 100 Gig-E is already in development and being talked about by the committees. So I think in our view, certainly we've worked with every one of these interfaces. In our view, the Gig-E interface is the one that's the most bulletproof, the one that locks up the computer the least and that causes the fewest problems. It's also the one that every programmer who comes into our place to start doing some coding already knows how to work with Gig-E. They know how to configure it. They know about IP addresses and routers and gateways and firewalls, and all of that is familiar territory for everyone. So the learning curve for understanding how to communicate between the camera and the computer is zero, and that is huge. The learning curve for dealing with a FireWire camera is very, very steep. And the learning curve for understanding how to work with CameraLink is similarly steep. So it certainly seems that the Gigabit Ethernet pathway is going to be the one that owns the bulk of the camera interface market over these next few years. Crystal balls are imperfect, but that certainly is the way things are looking right now.
Ned, once more, thanks for helping us make sense of the results of our Sensors and Vision survey. We really appreciate your putting it in context and sharing your analysis with other controls engineers. And again, to all the folks out there, if you haven't seen it yet, be sure to check out part 1 of this video for our survey's results on regular sensors at www.controldesign.com. I'm Jim Montague, and this has been another Control Design Market Intelligence Report.